Okay, so today we're going to look at conditional statements as well as looking at the converse and the inverse and the contrapositive of a conditional statement. So a conditional statement is really, it's nothing but an if-then statement. And one of the ways we like to look at this is this idea to say that if P, then Q. Like this can be anything. If anything, then anything. In other words, the if kind of causes the then, and it's just a way to reason through some of this. And so the thing that we're going to look at here first is this idea or this statement: if a figure is a triangle, then it is a polygon. Now, I guess the first thing to do is to remind you of just what a polygon is. Okay, so we'll start with that. And a polygon is just a figure that is three or more sides. You get that from this prefix poly, which means more than one. And so a polygon is any shape that's three or more sides. So this can include quadrilaterals, triangles, pentagons, hexagons, any shape that is three or more sides. And so what we're going to do with this chart is come up with these statements and then decide whether a statement is true or false. And so the first thing we're going to look at here is if a figure is a triangle, then it is a polygon. Well, we just got done saying that a polygon has three or more sides, and in this case, a triangle has three sides, so this statement is absolutely true. Now, the other part that that's going to happen here is if the statement is false, we're going to give what we call a counter example, and we'll talk about that here in a second as we do some of these other things. So the thing with the conditional statement is that it leads us into some other statements, okay? So the converse, and the idea of this converse is simply we're going to take our if-then statement and we're going to swap the if part and the then part. In other words, the if part will become the then part will become the if part. So as we go through this statement, it's going to be if a figure is a polygon. So we've switched triangle to polygon here. If a figure is a polygon, then it is a triangle. So we just take the if part, swap it for the then. Now the converse is something we'll talk about later. It's a very important idea. You're just switching the if for the then. So then I need to think about whether this is a true statement or not. And so I just want you to think about that for a moment. Is this a true statement? If a figure is a polygon, then it is a triangle. Okay, in this case, this is not true. This is false. Now we can talk about this idea of counterexample. So as soon as we say if a figure is a polygon, we can think about certain polygons. For instance, a square is a polygon, and a pentagon is a polygon. And so in order to come up with a counterexample, all I need to do is I can just write the word square. That would be a counterexample saying that this statement is not true. It is completely false. Now, in this case, if you wanted to draw a picture, perhaps we could draw an octagon. That would be another counterexample. But it just takes one, okay? It just takes one counterexample. Just one will cover it, okay? That it proves that the entire statement is false. Okay. All right. So that brings us to the inverse. The inverse is we are going to swap, actually we're not going to swap in this case, we are going to negate both the if and the then. So it's really just about adding a not to both parts, to both the if and the then part. We're just going to add the word not. So my statement in this case becomes if a figure is not a triangle. So we're going back to the original statement. If a figure is not a triangle, then it is not a polygon. Then it is not a polygon. So I want you to take a moment to think and to try to decide whether you believe that statement is true or false. Okay, so in this case, we're going to start with if a figure is not a triangle. So all I have to do is pick some figures that aren't triangles. And so if I pick a pentagon, for instance, a pentagon is a polygon that's not a triangle, so this one is also false. And as far as the counterexamples from the last one work as well. I did mention pentagon. So let's draw a pentagon. It could be a hexagon, and you can write them if you want. But the idea here is that there are lots of counterexamples. Okay, the contrapositive is where we're actually going to do both things. We are going to, it's really just a combination of the two, okay? Combination of inverse and converse. And in other words, we're going to swap them, and we're also going to add the word not. We're going to do both things. So the contrapositive statement would be if a figure is not a polygon, then it is not a triangle. So take a moment, in this case, take a moment to decide if that's true or not. Okay, this one actually turns out to be true. If a figure's not a polygon, well, then it can't be any of those shapes we keep talking about, and it will also not be a triangle. So like, for instance, a figure that's not a polygon might be a circle, which is also not a triangle. Now, it turns out that in this case, one of the big things to know here is that the original conditional statement and the contrapositive will always be the same. And the same is the same truth value, okay? In the same way, the inverse and the converse will also be the same. It is entirely possible that they're all true or that they're all false, but whatever the conditional statement is, that's also what the contrapositive will be, and whatever the converse is, that's also what the inverse will be. Okay, so let's look at another example here. So what you're going to be, I want you to try this on your own. So you'll notice here that it says if a figure is a quadrilateral, then it is a square. So I want you to use that last example and try to do this chart on your own. Goodbye.